Okay, good day. I am Mohaimen at Pasawilan, fourth year Bachelor of Science in Civil Engineering, Section A. So I'm here to present to you the RSA, or the Response Spectrum Analysis, dynamic analysis for 10-story building based on NSCP 2015. So the assumptions are the following. Columns are massless and infill walls are not present. For CA is equals to 0.44 and CV is equals to 0.64. For step 1, we're going to formulate the mass matrix and stiffness matrix. So from the given, ang ating first to 9th floor ay mayroong mass na 1.429 ton, while the 10th floor naman ay mayroong 1.089 ton. In terms of stiffness, first floor ay mayroong stiffness na 3727 million Newton over meter, and for the second to 9th floor, meron tayong 1779 million Newton over meter. And for the 10th floor, meron tayong 1511 million Newton over meter na stiffness. So by this given, we can formulate the mass matrix. So diagonal matrix, yung mass matrix composed of the mass of first to 10th floor. And for the stiffness matrix, so this 5506, for example, is equals to the sum of the stiffness of first floor and the second floor. So in here, 3727 plus 1779 is equals to 5506. So here, the 3558 is equals to the sum of the second and the third floor. Second and the third floor. So since third floor, second and third floor ay the same lang ang stiffness nila na 1779 million. So 1779 times 2 is 3558. So and so on. Here, sa baba, sa end, sa corner, the stiffness of the 10th floor. Next. So by solving the determinant of the matrix composed of the characteristics we got, so this is the formula for the characteristic equation. So by solving this characteristic equation and putting it into a matrix, since ang ating problem is 10-story building, so 10 by 10. So 10 by 10 matrix din yung malalagyan ng characteristic equation natin. So by solving the determinant of that matrix composed of characteristic equation, we got the eigenvalues for mode 1 to mode 10. So these are the eigenvalues for mode 1 to mode 10. And by getting the square root of these eigenvalues, so we can get the frequency. So these are the values of the frequency in every mode. So for example, for mode 1, meron tayong 5.6568542 and so on. And by using the formula 2 pi over frequency, or 2 pi divide frequency, so we can get the period. So we can get the period for every mode. So for mode 1, meron tayong 1.1107 and so on. And sa mode 10, meron tayong 0.0890717. So these are the values that we are going to use in the preceding, the next calculations. For step 3, we are going to calculate the eigenvectors for each eigenvalue. So for the eigenvalue of mode 1, the 32, substitute natin ito sa k minus lambda m na characteristic equation. So, solve natin ang eigenvectors ng eigenvalue na ito by using this calculation. So, we're going to multiply the matrix with the characteristic equation na na-substitute itong mode 1 natin na eigenvalue dito sa eigenvectors natin na ito. So, since walang magiging solution kapag wala isa sa dito sa ating sa value ng eigenvector natin ang may value. So we're going to assume that the value of this eigenvector for mode 10 or for 10th floor is equals to 1. So we're going to transfer this column sa kabila ng equal sign natin. So magiging positive yung 1511. Magiging positive yung 1511. So by solving this, so you can get the eigenvectors here. So we're going to get the inverse of this and multiply it into this vector. So by that formula or by that calculation, we can solve the eigenvectors for mode 1. And for mode shift, ito naman yung magiging mode shift for the eigenvalue which is equals to 32. So nag-satisfy siya sa mode 1 since nag-intersect lamang siya into the origin of our graph. For the mode 2, ganun din ang ating magiging calculations. So, i-substitute natin yung 284 na eigenvalue for mode 2 sa ating matrix that contains a characteristic equation, the K minus lambda M. So, ganun din, inilipat natin itong last column dito sa kabila ng equal sign. So, by using this and solving this, we're going to get these values for eigenvectors. And for the shape of this mode shape, ito ang magiging mode shape niya. So, yan yung graph ng ating eigenvector. For mode 3, ganun din. For eigenvalue number 3, so for mode 3 is 755, substitute natin. So, the same calculation. These are the values or the eigenvectors. And speaking of this shape, so ito yung ating shape sa mode 3. So, yan yung magiging graph ng ating eigenvectors. We are going to put it into a graph. So, nag-satisfy siya. So, meron tayong 3 na intersection. Meron tayong 3 na nag-intersect dito sa ating y-axis. So, that is the mode 3. For mode 4, which is equals to the eigenvalue of mode 4 is 1388, substitute natin. So, the same calculation, the same formula, and the same method. So, substitute we will going to multiply the inverse of this matrix to this vector. So, we can get these values for eigenvectors. So, this is the shape we're going to graph these values of eigenvector. For mode 5, this is equals to the eigenvalue is equals to 2130. So, substitute natin siya sa characteristic equation natin. So, we can solve the eigenvectors with the same method as yung nauna. So, ito yung ating magiging values or na-obtain nating values for eigenvectors. So, when you're going to graph it, ito naman ang magiging itsura ng ating graph. And for mode 6, the eigenvalue is 2870. So, if we're going to substitute that into our characteristic equation and put it into matrix, so the same method as in nauna, so you can get these eigenvectors or eigenvalue or eigenvectors. So, ito naman yung magiging shape ng ating mode 6. So, yan magiging mode ng 6 natin. So, for mode 7, which is equals to, the eigenvalue is equals to 3601. The same method, these are the obtained values for eigenvectors, and this is the mode shape. For eigenvalue mode 8, 4,240. Substitute natin sa characteristic equation natin. Same method, and these are the answers, or these are the obtained eigenvectors. And if you're going to graph it, ito naman ay magiging itsura. So, if you are going to inspect, meron tayong 1, 2, 3, 4, 5, 6, 7, 8. So, nag-satisfy siya sa mode 8 na shape. So, for mode 9, so the eigenvalue is 4,717. Substitute natin sa ating characteristic equation. So, the same method, and these are the values for the eigenvectors. So, if you're going to graph it, ito naman ang magiging itsura ng ating graph. And lastly, for the mode 10, which is equals to 4976 for its eigenvalue, substitute natin sa ating characteristic equation na k minus lambda m. So, the same method as yung mga nauna, sa mga mode na nauna sa mode 10. So, we can get these values for eigenvectors. So, if you are going to graph it, ito naman ang magiging itsura ng ating graph. So, para na siyang Christmas tree. So, participation of modes. So, in this step, we're going to compute the participation of modes. So, specifically, the gamma n. So, this is the modal participation factor, and the PMN, or the modal participation percentage. So, step 4, kukompute natin ang modal participation factor. So, paano ba natin i-compute itong modal participation factor? So, this is the formula. So, this modal participation factor is represented by this gamma. So, it is equals to L, or the coefficient vector, and n by 1 vector, divided by the m hat, or the generalized mass matrix. Or, in simplified form, gamma is equals to the inverse of the generalized mass matrix times the coefficient vector. So for L, or the coefficient vector, it is equals to the transpose of the mass mode shape matrix times M, big letter M, or the mass matrix, times the D enclosed by brackets, that is called directional displacement unit vector. For M hat, so it is equals to transpose of the mode shape matrix mass times the mass matrix and times the mode shape matrix itself. So in solving this, kailangan natin ng mga components. So for the mode shape matrix, ito yung ating mga nakuha kanina in solving. So this first column here is for the first mode, second is for second mode, third mode, fourth mode, fifth mode, and so on. At dito sa last column is the eigenvectors for 10th mode. So, since kailangan natin ng transpose ng mode shape matrix sa ating computation, so i-transpose natin siya. So, yung original na column dito sa mode shape matrix ay naging row dito sa ating transpose of mode shape matrix. For our directional displacement unit vector, ito ang kanyang value. So, 1, 1, 1, 1, 1 hanggang 10. So, ibig sabihin, i-consider natin lahat ang directional displacement in all stories. So, in given kanina, ang ating mass matrix. So, ito ang ating mass matrix. So, solve natin to. By using this formula, you can get, and for L, is equals to this vector. So, since ang ating L is equals to transpose of mass matrix, mode shape matrix, so it is 10 by 10 times mass matrix at 10 by 10 times the directional displacement unit vector, that is 10 by 1 vector. So, ang result niya is 10 by 1 vector. Ito na yung ating coefficient vector. And for the generalized mass matrix, so since ito ay 10 by 10, yung ating transpose, 10 by 10 matrix din yung ating mass matrix, and also yung ating mode shape matrix ay 10 by 10 din, so 10 by 10 din ang ating magiging result. So this is the generalized mass matrix. So by getting this coefficient vector and the generalized mass matrix, kukuha na natin itong gamma. That is the modal participation factor. So since if you are going to solve the modal participation factor in simplified form, so kukunin natin yung inverse ng ating generalized mass matrix. So ginamit natin yung ating formula sa ating Excel para makuha yung inverse ng ating generalized mass matrix. So ito yung ating naging result. So by using the formula, gamma is equals to L over m hat, or in simplified form, gamma is equals to inverse of m hat times L. So ito na ang ating mga modal participation factor. So for mode 1, meron tayong 1.27989. For mode 2, meron tayong negative 0.43635 and so on. And here in our last mode, ay meron tayong negative 0.001173. So for our step 5, we're going to compute the modal mass participation percentage. So it is represented by PM. So it is equals to M effective, or the effective modal mass, divided by the modal mass or total modal mass times 100%. So in computing the effective modal mass, we are going to use this formula, the Hadamard product of L, or our coefficient vector, and gamma, or the modal mass participation factor. So this is the solution. So M effective, or the effective modal mass, is equals to this vector, that is the coefficient vector, and Hadamard product with the gamma, or our modal mass participation factor. So in this Hadamard product, we're going to multiply these corresponding elements of these two vectors. So we're going to multiply this 8.82798 with 1.27989 and so on with these another elements of these two vectors. So as a result, this is the result of this Hadamard product. So 11.29889 for the mode 1, and so on for this 0.102124 mode 10. So the total of this for our M total is equals to 13.95. So the PM is equals to this vector. So how are we, paano natin ito kinuha? So this 11, for example, this 81% is obtained through dividing 11.29889 divided by 13.95. So the result is and multiplied by 100%. So this is the result, 81%. This 1.28013 for mode 2 is divided by 13.95 and multiplied by 100%, and the result is 9%, and so on up to mode 10. So this is our modal mass participation percentage. So spectrum curve. So in this step, we're going to compute the SA, or the spectral acceleration, and SD, or the spectral displacement. So this is going to be the step 6 of our response spectrum analysis. So in this step, determine natin yung ating corresponding spectral acceleration based on different modal periods using figure to weight the tree of NSCP. So, kanina, na-compute natin yung ating model periods from mode 1 to mode 10 using the formula 2 pi over frequency. So, for mode 1, meron tayong 1.11072. For mode 2, meron tayong 0.37284 and so on up to mode 10. So, in our assumptions, sa ating response spectrum analysis, meron tayong CA is equals to 0.44 and CV is equals to 0.64. So, we're going to compute muna yung ating TS and 0.2 TS since magagamit natin ito in determining the spectral acceleration using this figure 28-3 of NSCP. So, ang ating TS is equals to this formula, CV over 2.5 CA. So, by substituting these assumptions of us, so meron tayong 0.582 bilang ating TS. So, sa ating 0.2 TS, so since meron tayong TS na 0.582, multiply natin sa 0.2, magiging 0.116 ang ating 0.2 TS. So, ito yung magiging ating limits in determining kung saan ba dito na part ng ating graph, determine natin yung ating spectral acceleration. So, this is the overall computation of ating spectral acceleration for T1. Since yung T1 natin na 1.11072 is greater than our TS, which is equals to 5.82, greater than 5.82. So, ang ating magiging formula is CV over T. Since as indicates sa graph na ito ang ating magiging formula kapag greater than TS ang ating model period. So, SA is equals to 0.562 times gravity. So, if you multiply this 0.5762 times 9.81 meter per second squared, ito yung ating magiging spectral acceleration. And for mode 2 hanggang mode 6, since ang ating model period ay nasa pagitan ng 0.116 ito yung ating 0.2 TS at ay ang ating 0.582 na ito yung ating TS. Nasa pagitan lamang sila ng ating dalawang limits. So, ang ating magiging formula ay spectral acceleration is equals to 2.5 CA. So, i-multiply na natin yung CA, which is equals to 0.44 times 2.5. So, ang ating magiging SA is 1.1 G or the gravitational acceleration. So, if multiply this, so since the same lang yung ating mode 2 hanggang mode 6 na SA, so 1.1 G lang lahat. So, if multiply it yung 1.1 sa 9.81 meter per second squared, ito na yung ating magiging spectral acceleration, 10.791 meter per second squared. And for mode 7, so since yung 0.10471 is less than our 0.2 TS na 0.116, so we will use this equation. So 18.75 CA squared over CV times yung ating model period sa specific na mode plus CA. So by using this formula, ating magiging SA is 1.0339 G. Na kapag i-multiply natin itong 1.0339 sa value ng G na 9.81 meter per second squared, ito yung ating magiging spectral acceleration, 10.1423 meter per second squared. So, since yung ating mode 8, 9, at 10 ay less than 0.116 na ito yung ating TS natin, so you'll use this formula. So, i-multiply lang natin yung ating model period na Tn dito sa 18.75 times CA squared. So, yung CA natin is 0.44 while yung CV natin is 0.64. So, and the product is i-add lang natin sa CA na 0.44. So, ito na yung magiging result. So, for mode 8, meron tayong 0.9873G. For mode 9, meron tayong 0.9589G. And for mode 10, meron tayong 0.9452G. So, if we substitute the value of G na 9.81 meter per second squared, so makukuha natin itong 48 is meron tayong 9.6854 meter per second squared. For mode 9, meron tayong 9.4067 meter per second squared. And for mode 10, meron tayong 9.2724 meter per second squared. So for our step 7, determine natin yung corresponding spectral displacement. So paano natin na makukuha? So ang formula ng ating spectral displacement is ito. So SD na function of period and the damping ratio na xi. So ito yung xi. So is equals to SA or our spectral acceleration na nakuha natin kanina lang over the square of our frequency in that mode. So by using this formula, ito yung ating magiging results. So since ang compute natin kanina for mode 1 na spectral acceleration is 5.6525 meter per second squared and our frequency is 5.6569 rad per second squared. So ang ating magiging spectral displacement by using this formula ay 176.642 mm. And for mode 2, meron tayong spectral acceleration na 10.791 and frequency na 6.8523 rad per second squared. So if we divide this to the square of this frequency, ito yung magiging spectral displacement natin for mode 2. And the same also, we're using this formula and substituting these values for spectral acceleration and frequency. Ito yung ating magiging sagot. For mode 3, meron tayong spectral displacement na 14.293 mm. For mode 4, 7.774 mm. For mode 5, meron tayong 5.107 mm. For mode 6, meron tayong 3.760 mm. For mode 7, 2.817 mm. For mode 8, 2.284 mm. For mode 9, 1.994 mm. And lastly, for mode 10, meron tayong spectral displacement na 1.863 mm. So modal responses. So in these steps, we're going to compute the modal story forces, modal story shears, and modal story displacements. So step 8, compute modal lateral forces. So we're going to use this formula, Fn is equals to gamma n. So gamma n is a singular value times mass matrix. So it is a matrix times phi n or mode shape vector times SA subscript n or spectral acceleration for a specific mode. So this gamma n is a singular value and also this spectral acceleration, while this m is a matrix and this phi n is a vector. So these are the values of modal mass participation factor in all modes. So for mode 1, 1.27989 and so on for mode 10. For mode 10 is equals to negative 0.01173. So for our m, the value of our m or our mass matrix is this. So it is a diagonal matrix composed of the mass of every floor. So for our spectral acceleration in every mode, so ito yung ating gagamitin. And our mode shape matrix that composed of the mode shape vector in every mode. So for mode 1, itong first column, second column for mode 2, third column for mode 3, fourth column for mode 4, and so on up to mode 10 is itong ating last column. So for our lateral force sa ating mode 1, so itong 1.27989, ito yung ating modal mass participation factor for mode 1 times yung ating m, yung pinakita natin kanina na mass matrix, times yung ating phi 1, yung ating mode shape vector. So ito lang. So hindi na kasama to kasi mode 1 lang yung ating i-compute. So, itong column na to, ang ating consider. Ito yung value ng ating V1 times 5.6525 or the spectral acceleration for mode 1. So the result of this is also a vector. So F1 is equals to this result. So this means na ating first floor ay merong 0.78923 na lateral force. For second floor is merong 2.42238. And third floor meron tayong 99327 and so on. So this in our 10th floor, yung uppermost floor natin, meron tayong 7.87855 na lateral force. So take note, these are all in kilonewton since ating concern is lateral force. So ito ay nasa mode 1 pa lang. Mode 1 pa lang. So by using the same formula and method for remaining modes, we can determine the model lateral force for the story in its mode. So kung gagayahin natin tong method na to, so with these respective modes, so from mode 2 to mode 10, so pwede natin mag-compute yung ating lateral force in every floor and in every mode. So hindi na natin papakita lahat. So ito yung ating magiging overall result. So model lateral force, so ito na. So for mode 1, yung ating model lateral force is ito na column. For mode 2, ito na column. For mode 3, mode 4, mode 5, 6, 7, 8, 9, 10. So take note that these values are all are in kilonewton. So since ito ay model lateral force. So for our step 9, kukompute natin yung ating model story shear force. So paano natin yung i-compute? So using this formula. So ito yung magiging gagamitin natin yung formula in computing the model story shear force in every mode. So for F1, so iunatin muna natin yung lateral story shear force sa ating mode 1. So since ang magagamit natin in determining the model story shear force ay ating lateral forces. So nandito yung ating F1. So for mode 1 to. So for first floor, second floor, third floor, fourth floor, fifth floor, and so on. Ito yung last natin for 10th floor. So by complying this formula, so mag-start tayo dito sa taas. So 0 plus 7.87855. So ang result niya is ito, 7.8785. So the result of this ay i-add natin dito sa lateral force sa 9th floor. So ito yung magiging solution niya. Ito yung ating magiging result. So the result of this, i-add natin dito sa lateral force sa mode 8. So or sa 8th floor. So ito yung ating magiging solution. And this is the result. And so on. Yun yung magiging pattern up to hanggang sa umabot tayo dito sa ating first floor. So in the second floor, meron tayong 63.0782 as a result of these calculations. So itong 63.0782, i-plus natin dito sa lateral force ng first floor na 0.78923. So ito yung ating magiging solution. And this is the result. So this is the model story shear force of the mode 1. So mode 1 pa lang ito, itong V1. So it is the first floor, second floor, third floor, fifth floor, sixth floor, seventh floor, eighth floor, ninth floor. So these are all in kilonewton. So by using the same formula and method for remaining modes, you can solve for the model story shear forces on each story in each mode. So kagayahin natin yung magiging yung formula natin. So in solving the model story shear force ng remaining modes. So in its story. So by using those formula and those uh, steps in calculations sa remaining modes from mode 2 from mode 10, so ito yung magiging results natin. So for mode 2, ito yung ating magiging modal story shear force for first floor, second floor, third floor, fourth floor, fifth floor, and so on hanggang dito sa pinakababa for 10th floor. So for mode 3 ito, ang ating magiging modal story shear force for mode 4, mode 5, mode 6, 7, 8, 9, 10. So by using this formula, obtain natin itong result na ito. And take note, these are all in kilonewton. So for our step 10, kukompute na naman natin yung ating modal story displacement or yung ating delta subscript I superscript n. So ito yung magiging formula natin in solving this modal story displacement. So this modal story displacement or represented by this representation is equals to gamma n, or the modal participation factor for a specific mode, Vn, or the mode shape vector for the specific mode, and Sdn. So it is equals to spectral displacement for the specific mode. For delta 1 or the modal story displacement for mode 1, so ito yung ating magiging formula or the solution. So 1.27989, ito yung value ng gamma 1 or the modal mass participation factor ng mode 1. So yung ating Vn or yung ating mode shape vector, so ito. So for mode 1, ito yung ating mode shape vector. And this 176.642 in mm, this is the spectral displacement for mode 1. So the result of this is this vector. So the delta 1 or the modal story displacement for mode 1 is this. So for first floor, meron tayong 7.2593 mm. For second floor, meron tayong 52.9738 and so on. Nandito sa ating 10th floor, meron tayong 126.80832. So, yung ating magiging result natin dito ay all are in millimeters ang ating units. So, para mapadali yung ating presentation dito, so by using this yung formula, so ito yung formula na to, and method, so ito na method for the remaining modes. So since natapos lang natin yung mode 1, so meron tayong natirang mode 2 hanggang mode 10, we can solve for the modal story displacement for each story in its mode. So ito yung magiging result natin. So for mode 1, ito yung nasolve natin kanina. For mode 2, by solving the modal story displacement using the previous formula or the solution. So ito yung magiging modal story displacement natin for mode 2. For mode 3 ito. For mode 4, 5, 6, 8. For 7, for mode 8, mode 9, and mode 10. Modal combination. So we're going to use SRSS or square root sum of squares in this step or the modal combination. So modal combination involves the computation of peak responses. So these are the following: the peak story forces or F peak, peak story shear or B peak, and delta peak or the peak story displacement. So this is the formula of the square root sum of squares. So formula. So R max or the maximum response or the peak response is equals to the square root of the sum of the squares of the responses. So ito yung magiging general formula natin in solving the peak responses like the peak story forces, peak story shears, and peak story displacement. So for our step 11, i-combine natin yung ating model responses using SRSS to compute the peak story shear or the B-peak. So, una natin itong solve bago yung F-peak or the peak story forces kasi dito magbe-base ang pagkuha ng peak story forces sa peak story shear. So, from the given, ito yung nakuha natin kanina sa previous steps natin na model story shear. So, these are the model story shear for mode 1, for mode 2, mode 3, and for mode 4, for mode 5, and so on dito sa mode 10. So, ito yung ating mga model story shears. So, all are in kilonewton. So, ito yung gagamitin natin. Ito yung i-combine natin using the SRSS to compute the B-peak or the peak story shear. So, for the first floor shear or the peak story shear in the first floor, so since ang ating gagamitin na formula ay square root sum of squares, so ito yung ating magiging solution. So, for the peak story shear sa ating first floor, ito yung ating magiging solution. The square root of this 63.8675 is the model story shear for mode 1. And for this, 13.813 for mode 2, 5.0923 for mode 3, and so on. And this last 0.9469 is the model story shear for mode 10. So, ang ating magiging peak story shear sa first floor ay 65.659 kilonewton. And for the second floor, ito yung ating magiging peak story shear sa second floor. So, using SRSS, so ito yung ating magiging formula. And by solving this, ang ating makukuhang result for the peak story shear in second floor is 64.396 kilonewton. So, sabi dito, by using the same method, the SRSS, in finding first and second floor peak story shear, so we can find the peak story shear of third to 10th floor. So, as an overall result, so ito na yung ating magiging overall result. So, by using SRSS in third floor up to 10th floor, so ito na yung ating magiging answers. So, for third floor, ito yung ating peak story shear, 61.248 kilonewton. For fourth floor, 56.903 kilonewton. Fifth floor, 51.714 kilonewton. For the sixth floor, 45.769 kilonewton. Seventh floor, 38.946 kilonewton. For eighth floor, 30.993 kilonewton. For ninth floor, 21.582 kilonewton. And for 10th floor, meron tayong 10.460 kilonewton. So, this is our peak story shear in every floor. So, step 12 natin ay kukunin natin yung ating peak story forces. So, using also the model responses in SRSS. So, ang formula natin in computing the peak story force ay B peak minus B peak subscript I minus B peak subscript I plus 1. So, paano natin ito isosolve using this formula? So, yung nakuha natin kanina na peak story shear ay ito. So, by using these calculations, so since this is our formula, so yung ating peak story shear sa first floor ay ima-minus natin sa peak story shear ng second floor. So, 65.659 for the first floor, minus natin sa 64.396 sa second floor. Itong 64.396 kilonewton. So, ito yung ating magiging mga sagot. So, meron tayong 1.263 kilonewton as a result of this subtraction. And for the peak story forces in second floor, so 3.48 kilonewton. So for third floor, meron tayong 4.345 kilonewton. For fourth floor, meron tayong 5.110 kilonewton as a result of this subtraction. For fifth floor, meron tayong 5.945 kilonewton. For sixth floor, 5.822 kilonewton. Seventh floor, 7.953 kilonewton. For eighth floor, 9.411 kilonewton. For ninth floor, 11.122 kilonewton. And lastly, our peak story force in 10th floor is 10.460 kilonewton. Since wala na tayong isa-subtract dito sa 10.460 kilonewton na peak story shear sa 10th floor. So, minus 0. So, ito yung ating naging sagot. So, as an overall result, ito yung ating nakuhang peak story force in every floor. So, this is the formula. So, for our step 13, compute natin ang ating peak story displacements or the delta peak. So, ang ating given kanina, so ito yung ating na-solve kanina sa model story displacements. So, this is our for model story displacement for mode 1, for mode 2, 3, 4, 5, 6, 7, 8, 9, 10. So, first floor, second floor, third floor, and so on up to this last row, which is the 4th and 10th floor. So, ito yung gagamitin natin to compute the peak story displacement. So, ito yung kukombine natin using RSS or square root sum of squares. So, first floor peak story displacement. So, using SRSS, ito yung ating nagiging solution. So, delta peak 1, so square root of all peak story displacement in square root of model story displacement rather ng every mode. So 7.2593 for mode 1 square natin plus 3.697 square for mode 2 plus 1.3685 for mode 3 squared and so on up to this last term here 0.2603 for mode 10 squared. So, isa-square lang natin na lahat and the result is kukunin natin ng square root. So, ito yung ating magiging result, 17.735 millimeters. So, sabi dito, by using the same formula, the RSS, so square root sum of squares, and method for remaining stories. So, ang remaining stories natin, meron tayong second floor, third floor, up to 10th floor. So, we can solve for the peak story displacement for each story. So answer for as an overall answer by using SRSS and the method for remaining stories. So ito na yung ating magiging peak story displacement. So for mode 3 o for mode 2, meron tayong 54.157 mm. For mode 3, 88.690 mm. For mode 4, meron tayong 120.534 mm. Mode 5, 149.101 mm. Mode 6, 173.906 mm. For mode 7, 194.484 mm. For mode 8, meron tayong 210.345 mm. For mode 9, meron tayong 220.967 mm. And lastly, for mode 10, meron tayong 226.730 mm. So, ito yung ating nagiging overall result using SRSS in combining model story displacements para makuha yung ating peak story displacements. So for our step 14, we're going to solve the peak story drifts or the delta peak. So in solving delta peak, solve muna natin yung ating maximum inelastic response displacement or the delta M. So, yung delta M, ito yung gagamitin natin mamaya in solving this delta peak or the peak story drifts. So, ang formula in solving the delta M or the maximum inelastic response displacement is this 0.7 times R, which is the overstand factor, times the delta peak, where R is equals to 8.5 for the reinforced concrete special moment resisting frame. So kanina, nasolve natin itong peak model story displacement or peak story displacements. So for mode 1 ito 7.735 mm, for mode 2 meron tayong 54.157 mm and so on. So for mode 10 is equals to 226.730 mm. So since meron dito sa ating formula, ito yung gagamitin natin mamaya. So by using this formula and this method of calculations, so it is very simple, no? So isa-substitute lang natin yung ating R, which is 8.5, ating delta peak, which is this corresponding peak story displacement for every floor. So i-compute lang natin yan, i-multiply lang natin siya sa 0.7. So ito na ang ating magiging maximum inelastic response displacement in every floor. So for delta M for first floor, meron tayong 105.526 mm. For second floor, meron tayong 322.235 mm. 527.704 for third floor. 717.177 mm for fourth floor. Para sa fifth floor, meron tayong 887.153 mm. So for sixth floor, meron tayong 1,034.742 mm. For seventh floor, meron tayong 1157.180 mm. Meron tayong 8th floor, sa 8th floor, meron tayong 1,251.550 mm. So for 9th floor, meron tayong 1,314.754 mm. And lastly, meron tayong 1,349.044 sa ating 10th floor. So, since nakuha na natin itong delta M in every floor, which is the maximum inelastic response displacement, so pwede na nating magkuha itong ating peak story drifts or yung delta peak. So, dito na tayo sa solving peak story drifts sa ating step 14 ay yung ating delta peak. So, based sa code ng NSCP, it is stated na calculated story drift using the maximum inelastic displacement shall not exceed 0.025 times the story height for structures having a fundamental period of less than 0.7 seconds. For structures having a fundamental period of 0.7 seconds or greater, the calculated story drift shall not exceed 0.02 times the story height. So, by combining this provision in the code or the NSCP, so yung ating fundamental period na nasa ating mode 1 o di kaya ay ating yung period sa mode 1 natin. So, yun yung ating natural period or ating fundamental period. So, since may value siyang 1.11072 second na greater than 0.7 second na stated dito sa ating code. So the calculated story drift shall not exceed 0.02 times the story height. So in our assumption, meron tayong 3 meter na story height. So 3 meter, i-convert natin into millimeter, meron tayong 3,000 millimeter. So story drifts must not exceed 0.02 of story height based sa ating code. So for our maximum story drift, so i-multiply natin yung 0.02 times 3,000 mm is equals to 60 mm. So ito yung ating magiging maximum story drifts. So hindi lalagpas dapat yung ating story drift sa 60 mm. So meron man tayong magkukumpit mamaya na maglampas, lalampas sa 60 mm. So i-disregard natin yon at ang gagamitin nating story drifts ay yung ating maximum, which is the 60 millimeters. So this is our last step. So for solving the delta peak or the peak story drifts, ito yung ating magiging formula. So delta peak is equals to the delta M subscript peak 1 minus delta M subscript peak I minus 1. So anong ibig sabihin yan? So yung na-compute natin kanina na maximum inelastic displacement. So ito, in every floor. So ito yung ating magiging calculations by complying the formula above. So by complying this formula above, so itong ating maximum elastic displacement sa first floor, minus natin sa maximum elastic displacement I minus 1. So 1 minus 1. So 0. So since wala tayong 0 dito na value, so 105.526 minus 0. So ang magiging sagot is 105.526 mm. So saka na natin i-explain ito. So for second floor, meron tayong 322.235 mm. Minus natin sa ating first floor. So ang result is 216.709 mm. So for third floor, minus natin sa second floor. So this is the calculation. So this is the answer, 205.469 mm. For fourth floor, minus natin sa third floor. Ito yung calculation niya. So ang answer for peak story drift sa fourth floor, meron tayong 189.472. So for fifth floor, so 887.153 minus sa ating fourth floor. So 717.177. So ang ating magiging peak story drift sa fifth floor ay 169.976. And by copying the pattern in solving this, so ang ating magiging result ay for 6th floor, meron tayong 147.589 mm. For 7th floor, meron tayong 122.439 mm. For 8th floor, meron tayong 4.370 mm. For 9th floor, meron tayong 63.203 mm. And for 10th floor, meron tayong 34.291 mm. So as you can see, red color yung ating dito sa pinakalas na mga answers. So ito yung magiging final answers natin. So since na-compute natin kanina ang ating magiging maximum story drifts ay 60 mm. So lahat ng mga na-compute natin dito kanina na lumampas sa 60 mm ay hindi natin yun i-consider, bagkus ang ating i-consider ay 60 mm lamang. So from first floor up to 9th floor, lahat ng values na na-compute natin kanina na peak story drift ay greater than 60 mm. So, hindi natin to i-consider lahat. Instead, ang i-consider natin ay 60 mm in every floor from first floor to 9th floor. So, speaking of the 10th floor, since ang ating peak story drifts ay less than 60 mm, so i-consider natin na 34.3105137 ang ating maximum peak story drift or the peak story drifts for the 10th floor. So this is the result of our calculation in solving peak story drifts or the delta peak. So and that will be all. So thank you for listening and God bless us all.